Hello, Dan Groninger here for GE Inspection Technologies with another in our series of instructional videos for Mentor UT and Mentor Create. In today's installment, we're going to talk about color palettes, how they're used with the Mentor UT, primarily on the C-scan and on the E-scan objects. And we're going to start in Create. I've built a simple application here called a generic roto. It's just a one-panel application, but it has a C-scan, E-scan, most of the controls that we would expect to see if we were going to be scanning an area for corrosion. And what we're going to do is look at some of the controls that allow you to select a palette to go with specific functions on the instrument, and how you would go about creating a custom palette. First thing to be aware of is that there are two different types of palettes, one for thickness or time of flight data views, another for amplitude data views. So if you have your data source for a C-scan set to one of the time of flight modes showing thicknesses, you're going to use the time of flight palette. If you have an amplitude A, amplitude B selected, that will be using the amplitude palette. All right. We provide a number of standard palettes with Create, and you can also create your own custom palettes. Standard palettes are at the top of the list: rainbow, grayscale, color step. Some of the more common color palettes that you might want to use, but there are going to be times when you want to create a custom palette for specific purposes. We're going to look first at creating a time of flight palette, and we have something specific in mind. We have a test that we're going to look at here shortly, where the customer wants to scan a steel plate that is nominally 0.2 inches thick, but they grind a weld area on the plate, and they're interested in discovering if the grinding has taken away too much metal, if they've created a thin spot in the part. So we're going to create a color palette that gives us green above a certain threshold thickness, red below, so thin red is bad, green thick is good. All right, we're going to start doing this by creating a custom palette. So the palette editor in Create is a tool that's up here on the toolbar at the very top right corner. There's a tiny icon there that looks like an artist palette with a paintbrush. So we click that, pops open the palette editor. First thing we need to do is select whether we're working on an amplitude or a time of flight palette. We're going to do a time of flight palette. Then we have a set of cursors here that select a start and stop position for a segment of the palette. And what we're going to do is, just for example, set the start at 0, the end at 50%. I'm going to say I want to start at red, and at 50% I want to end at yellow. And you'll notice I have a red start, yellow finish at 50%, but it hasn't updated up here yet. To make that happen, click the Generate button. And now you see we've built a segment of the palette that goes from 0 to 50%, starting at red, going to yellow. We're going to make a second segment here, starting at 50, ending at 100. We're going to start at yellow, and we are going to end at green. So now I have created a palette that starts at red, goes through yellow, ends at green. In this case, we worked a little harder than we would have had to. We could have simply said start at 0, end at 100, start at red, end at green, generate, and it'll make a nice continuous spectrum from red to green. One more piece that we need to think about, and that is a missing line color. When we're scanning on the instrument with an encoded scan, we're doing pulse on position. We do a sweep of the probe every scan increment as we travel with the encoder. If we move the encoder too fast for the rep rate or the PRF that we've selected on the instrument, we can overrun the scan, in which case we get a blank line in the C-scan. So we have the opportunity here to set a specific color for that blank line, and we're going to say we want that to be black. Okay? Now we've generated our complete palette, so let's give that a name, and we're just going to call that training for now, and we're going to save that. It says color palette saved successfully. At that point we can close the editor. Now one little defect in Create, at least in the initial release of Create, is that you notice our training, if we open here and we look at our time of flight palette control, you notice training didn't show up here. What we have to do to make that list refresh is exit out to the app desktop and Create, and reopen our app, and when we come back in and look at our C-scan menu and go to time of flight, there is our training palette. So we're going to select our training palette, and we will make sure that both of the C-scan views, you'll notice time of flight, those are selected independently. So we're going to say training. We will select training. We go back here. It's already selected on that menu, so we're in good shape. Now when it comes to dealing with time of flight controls, the palettes, there are 2 more or 3 more controls that we need to think about. There's the time of flight color range. There is a min-depth color and a max depth color. Time of flight color range is actually just a helper control. Changes that we make here are reflected, cause updates to the min-depth color and the max depth color. These only apply to changes made to the time of flight color range controls on the instrument itself. If you make those changes here in Create, they don't update these controls automatically. So when you load the app on the instrument, you may not get the result that you expect immediately until you touch this control, which will cause these to update. Then suddenly you'll get the results you're expecting. What we're going to do now is we're going to look at this min-depth color and max depth color. And to start out, we're just going to say we want the min-depth color to be 0.001 and the max depth color to be 0.250. And what we're saying is we want the bottom end of our palette to be very close to 0. We want the top end of our palette to be at 1/4 of an inch. And if you recall, we started with green on the, or red on the thin side, green on the thick side. So the result of this is everything above 1/4 of an inch is going to be green. From 1/4 of an inch down to 1/1000th of an inch, we'll be progressing down through the greens, the browns, into the reds, and at 1/1000th of an inch or below, we're going to have red. Right? So what we're going to do is save this, build, all right. Now we've built our app. We're going to come over to our instrument. We will add the app that we just created. We had called that generic roto. All right, now we have generic roto down here in the lower left corner. Let's launch that. And this particular app is set up to work with our roto array probe. So we'll get our array nice and juicy there. Proceed. And I have a plate here that's nominally 0.2 inches thick. Let's clear our scan, start recording, and we'll record a scan. Now you remember we set a thickness at 0 1/4 inch. I see I have some different thicknesses set up on the overview. Let's set this back to 0.001 and 0.250. All right, now we have a nice continuous all right, just like we had on Create. And we have a thin spot showing on our C-scan. So now, if we set our min depth color, our customer is primarily interested in whether his plate is right about 195 thousandths thick. So his standard is greater than 196 is good, less than 194 is bad. So if I set min depth color control to 194, max depth color control to 196, that's taken our entire palette that we declared that went from red to green, and it squeezes it and says, if you look at the scale to go with the palette, the color that represents the lowest percentage point on the palette, red in our case, begins at 194 thousandths in thickness and goes all the way down to 0. Green, the rightmost color, or the highest percentage, or the 100% color in the palette, begins at 196 thousandths thickness and goes all the way up. So the entire palette from red to green is compressed into a region just 0.02 of an inch thick, from 194 to 196. So that gives us green good for the plate, for most of the plate, or red bad below 195. Now, any place that the instrument did not take a thickness reading, so the thresholds didn't break the gate, or for whatever reason we didn't take a reading, those areas are going to also be red. The no reading gets translated to 0, which is less than 194, so it's the most red color. And that's what we're actually seeing on the overview, or in the active window C-scan here on the right, where we're still going from 0.1 or 0.001 to 250. We are seeing a collection of 0 readings. So if I zoom in on that, we're actually seeing zeros, not just a thin area. Okay. Now, if we take this and go to 194 and 196, now we have exactly the same colors on the right and left. The rulers to the end of the C-scans are showing the same thing. The rulers are set based on part thickness, which is on the part menu, the material menu of the E-scan. The part thickness is set to 1/2 inch, so this ruler goes from 0 to 1/2 inch. The min depth color and max depth color, because they have compressed this palette that we created, you'll notice there's a sharp delineation from red to green happening just below the 0.2 mark on these rulers. Okay. Now there are also this other set of controls, time of flight color range, that are percentages. These interact. If I make a change here, let's say I set this the left side of the color range to 30%. I set the right side of the color range to 60%. What the instrument does is takes that 30% times the 0.5 inch material thickness and sets the bottom end of the pallet at 150. So 30% times half an inch, 150 thousandths result. So you'll notice a pretty constant red color from 150 down to 0. 60%, 60 times half an inch, 300 thousandths. You'll notice the green color is consistent from 300 thousandths up to 500 thousandths. And the entire palette is now scaled from 150 to 300. If we look at our min depth color and max depth color, those have been changed now by the instrument. When we changed that percentage, it changed the min depth and max depth to the 150 and 300. Now you'll notice if we put this back to 194 and 196, while our palette updates nicely, the time of flight color range percentages are still indicating 30 and 60%. So this is a one-way function. If you change color range, the instrument will change the min depth and max depth colors for you. If you change the colors manually, it does not update those percentages for you. So that's a little bit of an opportunity to get in trouble. When you build your app in Create, think about whether you would rather work in percentages or absolute numbers. For most applications, you're going to want to work in absolute numbers. So I would either hide this control or lock it, take it away. If you would rather work in percentages, leave that control and hide the min and max depth controls. I would choose one method or the other. For most thickness type applications, I would leave the min depth color and max depth color. So again, what we've done is taken our entire palette, compressed it to fit between min and max. Everything below min will show in the 0% color from our palette. Everything above max will show in the 100% color from our palette. So this gives us a very neat way to look at a hard red and green, good and bad way of looking at our C scans. Okay. Now let's take a quick look while we're in here at amplitude scans. All right, so there's an amplitude palette that goes from 0% white through blues, greens, yellow, all the way up to red at 100%. And we have similar control over our amplitude color ranges. We can take that palette and compress it in a way very similar to what we did with the time of flight palette. If I take the left side of this control up to 30%, let's say, now everything below 30% will be at the 0% color in the palette. All right. If I take the right-hand side of the control to 70%, now everything above 70% in amplitude, 70% full screen height and amplitude, will show in the most intense color, the 100% color of the palette. So if you notice, the upper end of my palette was red, so now a larger region of the ruler is showing red on this C-scan. I set the bottom of the palette to 30%. Everything below 30% is the white color that is the 0% color of the palette itself. I can link these two sides together, shift the entire palette up and down together. So this has the effect of creating sort of a contrast control. If most of your variation is happening between say 70 and 80% screen height and you want to really zoom in on that, compress your palette tightly, then move the entire thing up so that it resides from 70 to 80%. It'll give you much more contrast on your image that way. If you want to go back to look at the whole wide range, set the minimum to 0, the maximum to 100, and now you've got the most dynamic range visible at one time on the C-scan. So wrapping up, we looked at how to create custom palettes in Create, how to assign those palettes and make them available in an app, how to make adjustments to the C-scan display with minimum and maximum depth thresholds and how that affects the way the color palette is displayed. We looked at amplitude palettes and the controls that allow you to fine-tune your view of those. So again, thank you for joining me. This is Dan Groninger with GE Inspection Technologies, and stay tuned for the next installment in our video series on Mentor.